A flexible mold for facade panel fabrication. Complex geometry plays an important role in contemporary architectural design. The freeform geometry is usually broken down into smaller panels to be fabricated. The Cultural Center in Baku by Zaha Hadid Architects is an excellent example of this process. Usually for each unique panel, a mold is CNC machined from a block of material. We propose molding architectural panels on a flexible silicone or rubber membrane and present a method to give the membrane the desired shape by controlling boundary conditions and air pressure. How do we find the right boundary conditions? Let us take a look at the complete design and fabrication process. We start with a given design surface and a panelization of that surface. Now let us take a closer look at one of these panels. We take the panel geometry and approximated it by a larger quadratic Weingarten surface. We use the Weingarten surface in a box larger than the panel to get a set of 4 center lines of the pipe surfaces touching the Weingarten surface. These curves here in red are the initialization of our optimization process. We use physical simulation and optimization to improve the boundary curves and obtain a new set of curves, here in green. We use these curves to fabricate a membrane support frame. This frame is CNC cut from a thin board of engineered wood. Compared to machining the mold from a block of material, this is already a very efficient and cost-effective process. However, a fully reconfigurable mold can be constructed by replacing it with an adjustable support system. The actual molding process begins by positioning a support frame and laser distance sensor inside the machine. This sensor is used to control the membrane deflation process. Next, the membrane is installed. After initial inflation to avoid uneven prestress, the desired deflation is set at the digital controller, and the pressure in the machine body is lowered. Once the pre-programmed deflation is reached, the controller keeps the pressure inside the machine constant, and the mold is ready to use. An elegant way to fabricate a panel is the use of robotic 3D printing. Here we print the test panel 3 using plaster. We believe 3D printing of concrete directly into the mold would be a very exciting way to produce highly customizable concrete panels with a perfectly smooth outer surface. Another option would be to use a lamination process to produce fiber-reinforced panels. Our gypsum panel is cured after a few minutes and can be demolded. The machine is now ready for the next panel. To demonstrate that multiple panels form a smooth facade, we split a complex freeform surface into 9 panels and built a facade model. In this research prototype, the panels are manually cast and assembled onto a welded stainless steel frame. The resulting facade model shows a nice, smooth surface in the desired shape. Thank you for your interest in our work and for watching this video. The corresponding publication in supplemental material can be found on the project website.